Everyone, my name is David and I'm a student of SGO. Today I'm gonna solve one interesting problem from LeetCode. So let's start. The problem calls container with the most water. You are given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are i0 and I head I. Find lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. Notice that you may not slant the container. So that means we have to return the area that is maximum. So to do it, we need to calculate each area and return the most of them. So if the input will be like this: height. The first line. The head of first line is 1, second line is 8, 6, 2, and so on, and the output is 49 because most area is 49. So how to solve it? Let's discuss. So to solve it, we need to use algorithm that calls two pointers. And the first pointer is left, the second one is right. So first of all, firstly left will be equal to 0 because 0 is the first of the 0 index is the first of line in the array. And the right will be the last one, so n minus 1. The right will be, the left will be 0, and the right will be 0. So we need to move them and calculate area. Area is r minus l, and multiply by height of l. It will be multiplied by mean of height left and height right, because if we will take max like 7 and 1, the area will be 7 multiplied by r minus l. It will be 1, 2, 3, 4, 5, 6, 7, 8, 9. It will be 9, and it will be 63. It cannot be like this because the water cannot be like this because the line of height is 1. So that's why we take the minimum of them. So and after we have stored this value. We have stored this value to our variable max. And we have to store like max of variable max and current s, and that's why by this way we can find maximum of them. So under move left and right, when we will move left when head of left is less than head of right, because no need to calculate like this one because it will be smaller than this one in any way, and so that's why we need to move less line, and we need to move right if head of right is less than head of left. So by this way, let's solve this. So firstly, left will be 1 and the right will be left will be 0 and the right will be 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. And the S, our area will be equal to 8 multiplied by minimum of height of line and left and the right. The minimum is 1, and that's why the area is equal to 8, and we will store them. After, because of head of left is less than head of right, we need to move our left point. So let's move it. It will be there. At the first index, and the area, the second area will be minimum of heights left and right. The minimum is 7 and the distance between them is 7, and that will be equal to 49. So we store maximum of my variable max, and the s is 49, so it will be 49. And by this way, left is greater than r, and that's why we need to move r. So the r will be there, and the value of r will be 7. So the area of this currently less than this, and the height of right less than height of left, and that's why we need to move right. So they are equal. So let's calculate this area. The area will be 8 multiplied by 6 minus 1 is 5, and it will be just 40, and the 40 is less than 49. So we doesn't change the value of our variable max. They are equal, and no matter what we need to move, let's move left. Left will be second, and that's currently less than it. So after left will be moved, because the head of left less than head of right. So left will be there, and this is also currently less than this. So, and we move left because head of left less than head of right. That's it's also currently less than it, and we don't need to change our variable max, this value. So let's move left, because head of left is less than head of right. So, and also it is less than our max variable. So, and we will move left again, because head of left less than head of right. So when L and R are equal, that means we need to stop moving them, because there cannot contain any water. So, and we will return after all events the variable max. So that's all what we need to do. As I said before, we will solve this problem with the algorithm that calls two pointers, and the first pointer will be left will be equal to 0 because the left is the first line, and the right will be the last one. So that's why right will be equal to height length minus 1. So while as I said before, while left and the right are not equal, or left less than r, we need to calculate the area. Area will be equal to right minus left multiplied by minimum of heights left and right. So after that, before the loop, we need to create variable max, and it will be equal to 0 because the minimum area of containing water is 0, and that's why we need to max equal to 0. So each time we have to check our max, we need to do max be equal to max of max and the area, and after, if height of left less than height of right, it means we need to move our left to the next one. Also, we need to move our right to the previous, and after all, we need to just return maximum. So let's check. Accepted. Let's submit it. Yeah, accepted. We have done this problem. It works in 50 milliseconds, and I think that is a good result for this problem. So goodbye everyone.